So we started with circular permutation. In circular permutation, when the objects are arranged in a closed curve like circle, that is called as circular permutation. Here you will not have any starting point or ending point, or the first term and the last term will not be available. So when it is circular, it is something like arranging people on a round table, or arranging beads or stones in a necklace. Now since all the stones will be similar, or all the stones are in the circular format or in the closed curve, we will not be able to differentiate which is the first precious stone and which is the last precious stone. Okay, so that is not possible in circular permutation. So how do we solve the problem in such case? So there are two ways of solving the problem. The first way is we will just use this formula, that is n minus 1 whole factorial. Okay, n minus 1 whole factorial. So we'll use this formula to understand or calculate circular permutation. There is another way, or the second method of calculating is we will fix one of the person or object. Okay, now let's say A is sitting in the round table, so we will fix A's place and then we will calculate all of the other person's placement. So that is the second way of doing it. So leaving this one person, the rest of them will be arranged in the round table. Okay, so that is the next way of understanding the circular or solving the circular permutation. Okay, so that is given here, and we saw a note where if at all there is anti-clockwise or clockwise order, if it is not distinguishable, means if there is no difference between anti-clockwise or clockwise. For example, the pearl necklace, let's say the pearls, no matter the pearls is arranged from right to left or from left to right, it doesn't matter because everything are pearls only. So in that scenario, we will be able to or we are supposed to use this formula n minus 1 factorial by 2. Okay, so that was the main explanation. Then we went on to solve the problems. In that, the first problem, in how many ways can 8 persons be seated in a round table? So in a round table, how many can they sit? So according to first method, okay, we just have to use the formula n minus 1 factorial. So how many people are there in the in the round table? There were 8 people. So 8 minus 1 factorial, which is nothing but 7 factorial. So that will be the answer under first method. Another method is we are going to fix one person here, that is A, and rest all the 7 of them we are going to arrange them here in the permutation. So in the second method also, since 1 is fixed, out of 8 1 is fixed, the rest of them are 7, so we will arrange them in 7 factorial ways. You will get the same answer using both the methods. So that was your problem number 1. Now coming to the next problem, how many ways can 10 different precious stones be arranged in the to be a set of necklace? Now here, since you cannot distinguish if it is arranged from left to right or right to left. Okay, either it is in clockwise or anti-clockwise. We cannot differentiate. Why we can't differentiate? Because it is precious stones. So they are simply saying it is precious stones. No matter how you arrange them, it will end up with the same arrangement. So in that case, what was our formula? N minus 1 factorial divided by 2. Okay, so that was our formula. Now what is n here? N is 10. So 10 minus 1 factorial divided by 2. So 10 minus 1 is 9 factorial divided by 2. Now can you say me the value of 9 factorial? Calculate the value of 9 factorial. Okay, 9 factorial is 362880 and then divided by 2. Yeah, correct, Kirti Bhushan. 362880. Now divide that by 2. How much do you get? Okay, 181440. So this is the final answer for this problem. Okay, don't leave it at here. Continue. This 181440, that should be the final answer. Okay, now let us go to the next problem. Okay, in how many ways can 6 boys be arranged in a circle if two particular boys always wants to be together? Okay, so two particular boys always wants to be together. They are all standing in a circle. Okay, and there are totally 6 boys. So we have 1, 2, 3, 4, 5, 6. And I think yesterday I told you 3 and 4 always wants to be together. Okay, 3 and 4 always wants to be together. So what we will do is 3 and 4 will be 1 unit and rest 4 of them will be 1 unit. So 4 plus 1 is equal to 5 units. So 5 units can be arranged in 5 units can be arranged in not 5 factorial ways but n minus 1 factorial. If you remember this, in this place or in this case they are arranged in a form of a circle. Okay, so you cannot take 5 factorial ways, you have to do 5 minus 1 factorial ways. Okay, 5 minus 1 factorial ways. So this will be the arrangement that you can do, that is nothing but 4 factorial. So for, I'll just repeat it again. We are taking 3 and 4 as 1 unit because they always want to be together, and rest 4 of them are the separate people. So 4 plus 1, we have 5 units, but since they are arranged in circle and it is circular permutation, we use the formula n minus 1 factorial. So n minus 1 factorial is 5 minus 1 factorial, which is 4 factorial. So that is one part of the question. Now again we have 3 and 4 as 1 unit, right? So there are 2 people here who can rearrange themselves. Okay, 3 can come this side, 4 can go that side, or 4 and 3 in the same place. So these people can arrange themselves. So 2 people are there as 1 unit. So they will be 2 factorial. So 4 factorial is 24. 4 into 3 into 2 into 1. So 4 factorial is 24 into 2 factorial is 2. So your total answer is 48. So 48 ways you can arrange 6 boys in a circle where 2 particular boys always wants to be together. So this 48 is the final answer and it is 48 ways. Understood? Any doubts still here? Everybody understood? Okay. Now let us go to the next question. It's very similar to the previous question. Okay. Let us see what is there in this question. In how many ways can 5 boys and 5 girls be arranged in a circle if no 2 girls are together? Okay, this question at first instinct, if you see, it almost looks like the question of girls and boys standing. So we had 9 boys. So B1, B2, B3, B4, 5, 6, 7, 8, 9. And then we found what are the spaces that were available between so that the girls can stand. So because they're saying no 2 girls are together. So 2 girls will not stand together is what they're saying. So we had 9 boys and 6 girls where we were supposed to arrange them in a row, right? So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had 10 spaces for the girls where the number of girls were only 6 of them. Okay, now the same problem, instead of standing in a row, they are arranged in a circle. Okay, instead of standing in a row, they are arranged in a circle. So let us understand how to arrange them properly so that no two girls are together. Okay, did you understand the question? First and foremost, did you all understand the question? Okay, now let us go to the solution. Now, how many boys do we have? How many boys do we have? 5 boys. So first we will arrange the boys. Now, since they are saying us no two girls should be together, we will arrange girls later. Okay, first we will arrange the boys. Now they are supposed to be arranged in a circle. Okay, now 5 boys to be arranged in a circle. Now since we have 5 boys, okay, let's say B1, B2, B3, B4 and B5. Okay, so we have 5 boys who are arranged in a circle. Now, for circular permutation, how do you understand it is circular permutation? The question mentions they are arranged in a circle. So what is the formula for circular permutation? We have to find out n minus 1 whole factorial. Correct? For circular permutation, the formula is n minus 1 factorial. So how many boys do we have? We have 5 boys. So 5 boys can be arranged in 5 minus 1 factorial ways. So which is nothing but 4 factorial ways. Correct? 5 minus 1 factorial ways and 4 factorial ways. Boys can be arranged. Boys can be arranged in four factorial ways. Now moving on further, when 5 boys are in circle, there are gaps in between them. Okay, there are gaps in between these boys whoever are standing. Now let us fill those gaps using or by girls. Now here if you see how many gaps are there, 1, 2, 3, 4, 5. Okay, we have 5 gaps. So since we have 5 gaps and we also have 5 girls to be arranged where no two girls are together. Okay, so here there is no girl and girl sitting next to each other. So since 5 gaps are there and 5 girls are there, so we will be directly taking it as 5 factorial. Okay, you might get confused here saying why don't we use n minus 1 factorial? It is not necessary because first we have arranged the boys in a circle. Okay, first we have arranged the boys in a circle and there we have used the formula once. So that is enough. The leftover part we are arranging the girls. So there are 5 girls and there are 5 places. So we are arranging them in 5 factorial ways. Okay. Now, one more thing you'll have to understand. Now, here the positions are fixed. Okay, here little. Why do you seem it is fixed? First, we will fix B1, B2, B3, B4 and B5. Correct? After that only we are trying to cover the other places by filling the girls. So that is why we will go with this 5 factorial and we will not go by n minus 1 factorial once again. Understood? Are you all able to follow? Okay. So the total number of ways where I will be able to find or I will be able to get boys and girls in a circle is 4 factorial and 4 factorial into 5 factorial. Clear? Any doubts in the circular permutation? Everybody understood? Can we go for the next concept? So that completes our permutation part. Now let us go to combinations. So today we will understand what are combinations and how we are supposed to solve combinations, and what are the formulas that we are supposed to remember in combination. Okay. So I will send you few exercise problems today of permutation. Please try to solve. If the in case of any doubt, we shall discuss in the class. Okay. So let us start with combinations now. Okay. So first here, the different groups or collections or selection that can be formed out of a given set of things by taking some or all of them at a time is called as combination. Now here we will not even consider the order. Okay, we don't think, okay, first it is supposed to be let's take an example. I think that will be better for you to understand. Suppose we go to a vegetable market and we have fruits as well as vegetables. Okay, so let's say we have cucumber, then we have apple, then we have banana, then we have pineapple, and we have kiwi fruit. Now here there is no hard and fast rule that I'm supposed to start with apple and then with banana and then with kiwi and then with pineapple, and lastly if I will take cucumber. There is no rule like this. Okay, first I can pick anything that I want, or if I don't want any of this, I will go to a different store and I can buy onions or tomatoes. Okay, so in combinations the order of the arrangement will not matter. Okay, the order of the management will not matter. It is just the combination of things, or it is just joining two or more or all of them together. Fine. So let's take for example, another example we can take is, if you're baking. Okay, if you're baking, you would have to add all the ingredients. Let's say you want to prepare a cake. Now you should add all the ingredients one after the other in the prescribed recipe or in the mentioned order only. Okay, so that will not come here. But if you just add every other thing into that cake, you don't mind about the order. You just add everything into it and then you mix and bake it. So that will be a combination. Fine. So here, to use, or the formula to find out the combination is NCR. Okay, for permutation it was NPR, that was the representation. For combination you have NCR. Okay, and the formula for permutation was much easier, but combination you just have this n minus r into r factorial. Okay, so this is the addition. So here you had n divided by n minus r, but for combination the formula goes like this: n factorial by n minus r factorial into r factorial. But the rule is r should be less than or equal to 10. So you cannot have something like this 2C10. This is not possible. So R should be less than or equal to 10. You can have 2C2, or you can have uh, 5C2. This is also okay. Either R is this, R should be equal to N, or R should be less than N. Fine. So that is the formula for combination. Okay, now what does this say? The number of all combinations of n objects taken are at a time. So out of 2 objects, I am taking all the 2 objects. Out of 5 objects, I am taking 2 objects. Similar, the concept is very similar to permutation, but the only difference is in permutation, we will consider the order of arrangement. In combination, we don't. Understood? Okay. Now next, the word combination is generally used for selection of things, and word permutation is used for arrangement of things. This is very, very important. Very, very, very important. Mark it, underline it while you're writing. Okay. The word combination is generally used for selection of things. You just randomly select things here. You don't think about you have to buy first, you have to buy next. No, you just randomly select. But when it comes to permutation, you will have arrangement of things. There you are very particular which should come first, which should come next, and then only you will arrange. Okay, understood the concept of combinations? Any doubts? Everybody understood? Okay, so let us go further. Now, properties of combinations. This is also very important because we will be using all of these properties in solving the question. Okay, you just have to remember, there is no other way here. You just have to remember all of them. So NCR is equal to NPR by R factorial. Suppose in a question they have given you the combination NCR value, and they're also talking about permutation value. Then how do we find the relationship? So this clearly says the relationship between the combination and permutation. Okay, few problems. It's very rare because basics they might ask, they might not ask. So for our safety, we will just solve few problems in this also. So NCR is equal to NPR by R factorial. Then NC0 is equal to NCR is equal to 1. So if NC0, if R is equal to 0, okay, then NCR, this is also there, is equal to 1. You just have to take it as 1. So NC0 is equal to 1 is what they are trying to say here. If R is 0, it is 1. Then NCN minus R is equal to NCR. We will see this properties in solving the problem. You'll be able to understand them better. There are no proofs for this as of now, but while we are solving problems, we will be able to use the formula and arrive at the answer. Then if NCR is equal to NCK, okay, so K is a different number. Now if NCR is equal to NCK, which means N and N is also almost same and R is equal to K. Then either R is equal to K or R plus K is equal to N. This is very, very widely used formula. So NCR is equal to NCK is, if you get any of this format in the problem, which then it means that either R will be equal to K, or it's something like, let's say 2C1 is equal to 3C1, let's say. Now here either your R will be equal to K, so like this 1 and 1, or R plus K will be equal to n. We will take this as 2 only. Okay. So r plus k means 1 plus 1 is equal to 2. Any of this can be applied at salt. Then n plus 1 Cr is equal to NCr plus n into Cr minus 1. This we will solve a problem now. And then there is a series of combination given. This we will use it in statement problems. Now let's go to the problem. Okay. Apart from that, you have some more useful formulas. If at all in the problems they ask you to find if k points are collinear, and if there are straight lines, you have to form a triangle. All those times you have to use the certain formula. So you just have to remember all this. Okay. We'll find an easy way to remember later. Okay. Then if there are parallel lines, parallelograms, polygon, all that we will be able to do. And this also is a important formula. We already saw this formula in a different way, right? So the relationship between permutation and combination is NPR divided by NCR is equal to R factorial. So if you have the information about NPR and NCR, we will be able to find the R factorial. Okay, so that is your useful formulas. Okay, now let's start with the problems. Concentrate. The first problem. If NC4 is equal to NC5, find the value of N. Okay, so we do not know what is N. So they are asking us to find out what is N. Now, from the combination properties, we can understand that NCR is equal to NCK, then R is equal to K, or R plus K is equal to N. Either of one will be applied. Okay. Now let us see here. Now NCR is equal to NCK. NC4 is equal to NC5. So R is equal to 4, K is equal to 5. Now first condition is R equal to K, 4 is equal to 5. Yes, good, Imran. Is 4 equal to 5? No. 4 is not equal to 5. Since R is not equal to K, now let us check the second. This is the first condition. This is the second condition. Now, since first condition did not work, let us check the second condition. So, R plus K is equal to N. So, R is 4, K is 5, so is equal to 9, which is nothing but N. So therefore, the value of N is equal to 9. Now, which means 9C4 is equal to 9C5. Okay, so that is the answer. Understood? Did you all understand the first problem? That is enough. Only 9. We don't have any factorials here, so we will not be calculating any of the factorial part. Okay, so what you can do is, one thing how we can verify this is by using the formula. So what was the formula that we understood of combinations? N factorial by n minus r factorial into r factorial, correct? So we can use this formula and find out 9C4 is equal to 9C5. Okay, so n is 9, 4, r is 4. So first we will find for this. 9 factorial by 9 minus 4 factorial and 4 factorial. So 9 factorial by 5 factorial. 9 minus 4 is 5. Okay, 4 factorial. So 9 into 8 into 7 into 6 into 5 factorial. Okay, divided by 5 factorial and 4 factorial. Now I can cancel 5 and 5 factorial. 5 factorial, 5 factorial I can cancel. So how much is the value of 9 into 8 into 7 into 6? Can anybody calculate and say me fast? 9 into 8 into 7 into 6. 3024. Okay, 3024 divided by 24. 4 factorial is 24. So 3024 by 24 is 126. Okay, so 9C4 is equal to 126. So we got one answer. Now find out the value for 9C5. Now what is the value for 9C5? Same formula, 9 factorial by 9 minus 5 factorial and 5 factorial. So which is nothing but 9 factorial, 9 minus 5 is 4 factorial and 5 factorial. So next step what I will do, 9 into 8 into 7 into 6 into 5 factorial divided by 4 factorial and 5 factorial. Now I can cancel 5 factorial and 5 factorial, correct? So how much is remaining? Again you will have 9 into 8 into 7 into 6, which is nothing but 3024 divided by, again you will have 4 factorial, which is 24. Okay, again you will get 126. So if you see, NC4 is equal to NC5. So both the places we got 126 as the answer. Understood? Any doubts in the first problem? Can we go to the next problem? Everybody understood? I want everybody to reply. Okay, now going on to the next problem. Find x. So we are supposed to find x. So we will see the question. If 99C40 plus 99CX is equal to 100C59. Okay, so this can be solved using one of the property of combination, that is nothing but n plus 1 CR is equal to NCR plus NCR minus 1. Okay, now let us apply this first. Now n plus 1 CR. Now what is n in both of these cases? What is the value of n given here? What is the value of n? 99. So 99 plus 1 C 59. Okay, That is what is, that is how you can write this. Okay, 99 plus 1 C59 is equal to 99 C40 plus 99 Cx. We have to find this x. Now x is nothing but r minus 1. X is nothing but r minus 1. Let me rewrite this neatly. I think you'll be able to understand. I'm just rewriting this for the question itself in this format. Okay. So first you have 100C59. So I'm writing that as 99 plus 1 C59 is equal to, I'm just writing it from this side. So next is NCR. So NCR is 99 C40 plus the next part. NCR minus 1 is 99 CX. So you can say R minus 1 is equal to X